For this lesson, we're going to be looking at function notation. And in our new unit, while we look at functions, it's important that we're using the proper terminology and the proper notation. So from now on, instead of writing y equals 3x minus 4, we would write f at x equals 3x minus 4. So f with x in brackets. And again, we would say f at x. And what that means is it's the value of the function named f at the given x coordinate. So for example, f at 2 means the value of y when x equals 2. In other words, f at 2 is the y coordinate when the x coordinate is replaced by 2. Similarly, we could have something like y equals 1/2 x plus 1 plus 5, and we would rewrite that as g at x equals 1/2 x plus 1 plus 5. And we would say g at x. And again, that would be the value of the function named g at the given x coordinate. So let's do a few examples here. So for m at x, so this whole thing is m at x, we first need to find m at 2. So what that means is instead of writing an x in the equation, I'm just going to write a 2. So we write m at 2 is equal to negative 2 times 2 squared plus 4. And then we just simplify using BEDMAS. So of negative 2 times 4, that will give us negative 8 plus 4, which gives us negative 4. So m at 2 is equal to negative 4. Now sometimes we can make these a little bit more complex. So for this next example, we have 2 times m at 1. So 2 m at 1 is equal to 2 times, then my m at x, but instead of writing an x, I'm going to write a 1. There we go. And again, we just use BEDMAS to simplify. And so 2 times m at 1 is just 4. Let's try one that gets a little more complex. So now we have m at negative 2 minus 3. So I'm going to find m at negative 2 and then just subtract 3. So we'll start with m at negative 2. So instead of writing an x in the equation, I just put a negative 2. And then we just subtract 3 from all of that. So that will give us negative 2 times 4 plus 4 minus 3, negative 8 plus 4 minus 3. So negative 7 would be our final answer. But you can start to see how this is a little bit easier and more straightforward than writing it how we would have in grade 10. So let's try another example that's a little different. So for f at x equals 2x minus 1 and g at x equals x plus 4 all squared minus 7, let's first show that g at 2 is greater than f at 2. So I'm trying to show that g at 2 is greater than f at 2. So let's start by finding g at 2 and f at 2. So g at 2 will be 2 plus 4 all squared minus 7. And we're trying to show that that is greater than 2 times 2 minus 1. So this will give us 6 squared minus 7 and 4 minus 1. So we have 36 minus 7, and we're seeing if that's greater than 3, and we get 29. Oops, 29 is greater than 3. So we've shown that g at 2 is definitely greater than f at 2. Let's try another one. So now we'll determine f at 0 plus g at negative 2. So f at 0 plus g at negative 2. And that is equal to, we'll rewrite f, but instead of an x, I'm going to put a 0. And we'll add that to g at negative 2. And all I'm doing is just simplifying with BEDMAS. So our final answer is just negative 4. Now let's try one that is a little bit different. So for example C, we're going to determine g at 3b. So just like we were doing before, wherever I have an x in my equation, I'm just going to write 3b this time. So g at 3b will be equal to 3b plus 4 all squared minus 7. Now simplifying this one is going to be a little bit different because we're not just going to get a single number. We can't evaluate it and get one whole number or a fraction as our answer. We need to expand and simplify. So let's start by expanding out those brackets. And now let's use our FOIL steps to expand that. So we'll have 9b squared plus 12b plus 12b plus 16 minus 7. So then when I collect like terms, I'll have 9b squared plus 24b plus 9. That's my final answer. So exact same idea, just a little bit more challenging with the algebra. So let's try a few more examples that are all a little different. So example 3, for j at x equaling 3x plus 10, we want to find the value of x when j at x equals 28. So let's rewrite out j at x. This time we're given that j at x is 28. So instead of writing j at x, I'm just going to write 28. And now we can solve for x. So we're just isolating x here, which we've done before. So we'll start by moving the 10 over. There we go. So that will give us 18 equals 3x. And we just continue to isolate to get that x all by itself. So we divide out 3 and we'll get 6 equals x. Now for example 4, we have h of x equals x squared plus 20, and we want to find the value of x when h at x is 24. So we're going to approach it the exact same way. I'm going to start by writing out h at x equals x squared plus 20. And instead of writing h of x, I'm just going to write 24 equals x squared plus 20. And now I just want to isolate x. So I'll move over 20. 24 minus 20 equals x squared. 4 equals x squared. And now to isolate x, I just square root both sides and I'll get plus or minus 2 equals x. Now our final example, we have c at x equals x plus 1, and p at x equals 2x. So using that, we want to evaluate the following. So let's start with p at negative 2x. So I'm just going to write out my p of x, but instead of writing an x, I'm just going to write negative 2x. So I have 2, then instead of writing that x, I write negative 2x. And when I simplify that, I'll have negative 4x as my final answer. So same idea, just a little more challenging. Let's try b. So I just want to make sure we can also see c at the top. So we're looking for c at 3x minus x squared minus 1. So we want c at 3x minus x squared minus 1. So we're going to take our c equation, but instead of writing an x, we're going to write out this whole long-winded thing. So we will have, instead of writing x, 3x minus x squared minus 1, and then we have the plus 1 at the end from my original c equation. And then I'm just going to collect some like terms. So our negative 1 and 1 cancel. I'm left with 3x minus x squared. For example C, I'm looking for c of 4x plus 1 minus p at x minus 5. So I'm just going to quickly rewrite what c at x was. So it can be right at the top here. So this is equal to our c at x function, but instead of writing an x, I'm going to write 4x plus 1. And then that would be plus 1 minus p at x plus 5, at x minus 5, minus 2 times x minus 5. And now we can simplify for x plus 2 minus 2x plus 10, and then that will give us 2x plus 12 as our final answer. One more example, we'll just copy this and bring it over. There we go. So now we have c at 2 plus p at 8x squared plus 4x minus 5. So for c, instead of writing an x, we're just going to write a 2. So we have 2 plus 1 plus. Now for p, instead of writing an x, we're going to write 8x squared plus 4x minus 5. So 2 times 8x squared plus 4x minus 5. And that will give us 3 plus 16x squared plus 8x minus 10. And then when we collect like terms, we'll get 16x squared plus 8x minus 7 as our final answer.